First of all, I want to understand the key concept of what is a vector. Now, who in here has looked at a vector before? Okay, so some of you have. So can you tell me what you think a vector is?
I mean, in computer science, we use like vectors and also metrics, and they were used to, represent basically data from nature.
Good. So that is actually one definition which I will take for what a vector is, okay? It is just simply a list of numbers, okay? So just simply a list of numbers, and that list kind of has dimensions to it, and it's particularly useful, for example, for storing data and trying to pull out data from that list.
Also, one more additional thing, but they also use quantum computing,
Yes, absolutely. Yeah. So effectively, if you're familiar with computing, you're familiar with coding, okay, you will be very familiar with the idea that a vector is a list of numbers, and then you can perform operations on that list, okay? Yeah, so that's one definition of what a vector is. Has anybody got another definition?
Like shows direction.
Good. Is it just direction? So it's a quantity, so I'll go with that. So it's a quantity with direction and magnitude. Okay, so it's a quantity with direction and magnitude. Now, what do I mean? What do I mean by magnitude? Does anybody know? So magnitude is just simply a fancy word for size. Okay? Just a fancy word for size. Okay, so it could be how heavy something is, could be how tall something is, could be how long something is, could be how much time something takes. Okay, it's just simply a fancy word to describe size. Okay, you're all familiar with what direction is? Okay, so sometimes direction can be given explicitly, in other words, in that direction, in other words, north. Okay. Or it could be given as a relative direction. So in other words, if you move in that way and another person moves in that way, one would be the negative of the other. Okay, so it doesn't matter which direction it is, whether it's north, south, west, what bearing it's on or whatever. It's just a relative direction relative to somebody else. Okay, so it's either an explicit direction or a relative direction. Does that make sense? Okay, good. Is there a third one? There is a third one, but can anybody come up with it for me? Does anybody know? Okay, so it is a quantity, so it's a movement, okay? So it's a movement from one point to another, okay? So there you go. There are three equivalent definitions of what a vector is on the board. So the first one we came up with is kind of from this perspective of computing, okay? Now, in actual fact, this does extend into mathematicians, like if you're talking from an algebra point of view. There is an area of mathematics called linear algebra, which we will kind of dabble in a little bit when we're talking about vectors and matrices. But if you ask a mathematician, like a pure mathematician, what is a vector, they will say it's just a list of numbers, an n tuple of numbers, where n is the size of that list. Okay.
So also can I ask something? What do mathematicians do with all these crazy formulas with linear algebra?
It's a really good question. Okay, so traditionally, mathematicians kind of fall into two camps. Okay, you are either a pure mathematician or you're an applied mathematician. And actually, there's a little bit of rivalry between the two. Like, I'm an applied mathematician, I fall into that camp, but then some of my friends are pure mathematicians, okay? So there's a bit of rivalry between the two, and actually the way which the maths department here at Essex used to be constructed, there used to be like a long corridor, and on one side of the corridor was the pure mathematicians, and on the other side of the corridor there was the applied mathematicians. So it was literally like a corridor dividing the two, right? So an applied mathematician kind of takes mathematics and tries to use it to solve real life problems. So I think I've told you before, like I'm a mathematical biologist. In fact, I've moved a little bit more into psychology now, but I'm a mathematical biologist originally. And so essentially I was looking at trying to use mathematics to understand the movement of dairy cows, okay, and trying to understand lameness and sort of non-lameness from that. So I'm very much using mathematics to solve real life problems, okay. Engineers could be described as mathematicians in a way because they're using mathematics to solve problems, like they're using mathematics to build things, okay? And to make sure buildings don't collapse and things like that, okay? Whereas the pure mathematicians are the people that just do maths because they enjoy it, okay? Just for the sake of it, right? So they look at something and go, that's interesting, I'm going to play around with that anymore. It doesn't necessarily have a use, but it's just doing it because they enjoy it and because it's fun, okay? So there's kind of a bit of a rivalry between the two. So I think your question is, you're kind of asking about pure mathematicians versus applied mathematicians. Honestly, do these really have a use? Well, some of them do, and I will talk a little bit more about the use of matrices a little bit more.
I mean, sorry for interrupting, but we use like matrices in like also AI programming.
Yes,
and
absolutely.
also,
Absolutely.
Circuit building as well.
Right, and so the topic of matrices in particular is still relatively new, because you think 30 years ago people were looking at matrices, looking at vectors. So this is not a new topic, but they were looking at purely for fun. Okay? Now actually matrices has come more into the applied sense because they're realizing if you have large volumes of data, like in artificial intelligence, or for example when Google, they run like, when you type something into Google, brings all the search results back, they actually realize that matrices are really useful there. And the operations which people used to look at for fun are now actually really, really useful. Yeah? So just be aware that just because I'm talking about this, it does have a use, but it may also just be because people have looked at it for fun, okay? So anyway, so a list of numbers is more the computing algebraic definition. A quantity with a direction and magnitude, where would you typically see this? So who would typically treat a vector as a quantity with a magnitude and direction?
Addition?
Yeah, physics. Okay, so in physics, you ask a physicist, what's a vector? They say it's a quantity which has a magnitude and direction. It's kind of the equivalent between speed and velocity. Okay, speed is just how fast you're traveling. Velocity is how fast you're traveling with a given direction or relative to somebody else. Is that okay? Right? It's the same thing between like mass and weight and things like that. Okay. This is the definition which I want us to focus on though. So it's a movement from one point to another. This is the geometric perspective. So I quite like vectors because they're really useful when you're trying to understand geometric situations. Okay. So it's just a movement from one point to another. Now you say, well, hang on a minute. We already have a really good way of thinking about movements, okay? And that's using the coordinate plane. So literally, if I draw myself a little coordinate plane, this is x and this is y, this is two-dimensional, okay? Then are you happy that I can get anywhere on this board simply thinking about movements left and right and movements up and down with respect to an origin? Yeah? So you're happy we can already describe that. But the issue is, okay, so we work really well in Cartesian coordinates. By the way, does anybody know why it's called Cartesian coordinates? Does anybody know? It's named after a mathematician called René Descartes. He was literally lying in bed, like, really ill one day, and he saw a bee, or a fly, buzzing around the room. He was like, I can describe that bee's position with respect to like my wardrobe or something. So literally with respect to like an origin.
I bet he was on something.
Sorry?
I bet he was
He was French, so probably, yeah. Anyway.
Okay, good.
I'll say that again. So Cartesian coordinates. We're really good at describing movements and positions thinking purely in terms of this. So movements left and right and movements up and down with respect to a fixed position, okay? The issue is though, if we try and go into the third dimension, this still works, but it's really messy, like really messy, okay? So if you want to try and describe like planes, if you want to describe things like normal vectors, normal sort of things, they're really difficult to describe without understanding this idea of vectors. So vector just kind of cleans everything up as soon as you go into the third dimension, okay?